Okay, the handout that I gave you will come up throughout this lesson. And some of it I will work up here on, work through some of it with you from up here, and it won't be on the Nearpod part of it. So we're going to go into chapter 2. We're basically finished with chapter 1 now. Excuse me. And we're going to start off talking about frequency distributions. And the reason we need to talk about these is because if you have a large data set, excuse me, when you're working with a large data set, it's helpful to organize and summarize that data by making it into a table instead of just looking at a whole bunch of numbers and trying to make sense out of it. The frequency distribution also helps us understand the nature and the spread of a set of data. They show how all the data is partitioned among several categories, or we call those classes most of the times, by listing the categories along with the number of data values that falls into that category. Now, if it's qualitative data, then basically we're going to look at the different possible values of the characteristic, like, for example, freshman, sophomore, junior, senior, or what color people's eyes are, and then put the frequency or the count of the people that fit those classifications in that category. Now here's a set of data. This is men's and women's pulse rates for a sample of females and males. Now if I just look at those pulse rates, they actually look pretty similar to me. And I can't really tell too much about the women's pulse rates at all because they're just a whole bunch of numbers. They're not arranged in any particular order. So it would be easier to make a frequency distribution of this information. So what I've done in this frequency distribution is I've chosen the lowest value of the pulse rates, which happen to be 60, and made up classes that are incremented by 10. So the first group goes 60 to 69, and the next group goes 70 through 79, 80 through 89, 90 through 99, 100 through 109, 110 through 119, and 120 through 129. And then I went through the data and I counted how many women had pulse rates in the 60s, and there were 12. And then how many women had pulse rates in the 70s, and there were 14. And how many had pulse rates in the 80s, and there were 11. And then the 90s, there was 1. In the hundreds, there was 1, from 100 to 109. From 110 to 119, there were no women that had that pulse rate. But there was one woman that had a pulse rate that was 120 to 129. This tells me that the majority of women, easily the majority of women, have pulse rates between 60 and 79. Because 26 out of the total number of women had that pulse rate. So they all had fairly low pulse rates. And that's actually the normal range of pulse rates. Some terminology about this table, those bottom numbers for each category are called the lower class limits. That's the smallest data value that you could put in that class. There weren't any pulse rates in the 50s. If there had been, I would have had to have had another class that started at 50 to 59. So these are all the lower class limits. The upper class limits are the higher number for each one of the intervals. And one of the things to notice about these is that all the lower class limits are 10 units apart. And all of the upper class limits are 10 units apart. So all these classes have the potential for 10 different values in each class. Sometimes we represent the class by its midpoint because if we make a graph, it's much simpler to label the different categories by their midpoints if it's numerical data. The midpoint of 60 to 69 is 64.5 because there are 10 values from 60 to 69. The first 5 of those values would be 60 through 64, and the last 5 are 65 through 69. So halfway between the 4 and the 5 is where the class midpoint is. And it's easier to figure out how the midpoint what midpoint is by adding those two numbers together, 60 plus 69, and then dividing by 2. And that's how you can come up with the 64.5. And you can actually do that all the way down, but if you remember that these are all 10 apart, and these are all 10 apart, you really only have to calculate the first one, because you can just add 10 to the first midpoint to get to the next one. That class width is very important in that table. And that class width all the way throughout that table is 10. So the class width is the difference between two consecutive lower class limits. Class midpoint is halfway between the upper and lower class limit. Now, why would you want to make a frequency distribution? Well, for a large data set, you can summarize it better in a table than you can looking at the data itself, and you can analyze the nature of the data. And we also will have a basic tool that we can use to construct a graph. Because a table's nice, but a picture's worth 1,000 words, and a graph is a picture of the data. So we're going to try an example, and it is on page 1 of your handout. I'm going to pause this for a second, and we're going to go here. Okay, on your handout at the very top of the page, it just gives you the topic that it's frequency distributions, but then it explains how to calculate class width. You know what the class width is? It's the number of values that's possible for each class. It's the distance between all of the lower class limits from each other, and it's the distance of all the upper class limits from each other. But you need to know how to calculate a class width to get a table that has a certain number of categories. So the way that we'll calculate it is we're going to take the maximum minus the minimum and divide by the number of classes. And this is very important. Even if you don't come out with a decimal, you're still going to round up. You have to round class width up. And you round it up to the same number of decimals as the data. And the reason that's important is because if you're talking about money, money is going to be given in two decimal places. You don't want to round your class width. For example, I asked y'all about the amount of change you had. I wouldn't want to round my class width up to the nearest dollar, because that means all of my data would wind up in the same class. So I would want to round it up to the nearest penny for the class width. So you round it up always, but it's to the same number of decimals as your data is. And then you're given some examples here. 150 minus 45 over 8. Well, 150 minus 45 is 105 over 8. So we'll use the calculator. And we get 13.125. Which would round to 14, assuming that the data was integer values. And I know normally your arithmetic teacher would always say, no, that would round down to 13. In statistics, when you're making this table, it has to round up. It has to go up to 14. So if I were dividing that same amount by 6, I would get 17.5, which would round up to 18. Yes?
I know there must be a reason that you're saying to always round up, but it's not immediately apparent to me.
I will make it apparent to you in just a minute. Okay, because a lot of times students will have that question. So you do need to understand why it is that you round up, and I can show you why you need to round up. Okay? And then we have the same thing, we're going to divide by 7. So that one actually comes out even. It comes out to be 15. But you have to round up to 16. Now here's the why. We're going to take this one as the example. Let's suppose that I have a whole bunch of numbers, and they go from 150, or I'm sorry, from 45 to 150. If I set up my classes, the way that I should set up my classes is to start with the 45. And then I add my class width, which in this case should be 16, but I'm going to try to use 15. So 45 plus 15 is 60, and 60 plus 15 is 75. 75 plus 15 is 90, and 90 plus 15 is 105. And this is supposed to be 7 classes, so I have 1, 2, 3, 4, 5. I need a couple more. So 105 plus 15 is 120, and 120 plus 15 is 135. So 1, 2, 3, 4, 5, 6, 7 classes. But now I'm going to put in my upper class limits. So because this class starts at 15, this one must have ended at 59. And this one starts at 75, so this one must have ended at 74. And notice that these numbers are all 15 apart also. So this would be 89. This would be 104. This would be 119. This would be 134. And since I don't have another number to look at, I'll just need to add my 15. 134 plus 15 is 149.
9.
Where does 150 go? I don't have a class for 150. Okay? That's why you round up. If you don't round up, your last class won't have sufficient room in it for your highest data value. So that's why you round up. Okay? So rather than making this frequency distribution, I should have been using 16. And if I use 16, I still start out at 45. But then I add 16 to 45. And I'm going to make it easy on myself. I'm going to put 16. And then, I'm sorry, not 16, please. I'm going to start out at 45, and then I'm going to add 16 repeatedly until I get the rest of the lower class limits. So I go 45, 61, 77, and actually I could have just looked at this since I've already done it. And 93. And 109, and 125, and we need one more, so 141. So I have 1, 2, 3, 4, 5, 6, 7 class intervals, and this one goes up to 60. This one goes up to 76. This one goes up to 92. This one will go up to 108. This one will go up to 124. This one will go to 140. And 140 plus 16 is 156. And my 150 will go here, but it wouldn't go there. Okay? So there's the why of rounding up. If you don't round up, your frequency distribution won't be large enough in the last class to contain your highest data value, and you won't have any place to put it. okay? And basically, there's an explanation. The class width is the difference between two consecutive lower class boundaries or two consecutive upper class boundaries, or class limits, lower and upper. I'll explain what a class boundary is in a little while. The class boundary has a very good meaning if it's numerical data. If it's not numerical data, it's qualitative, then it has no meaning. So, for example, and we're going to do this problem here, this example with the bears. And I could make you do it without technology and do this all by hand, okay? But I'm going to kind of save us a little bit of time and show you how the technology will be very useful in doing what we want to do, because what we're going to need to do is we need to know the highest and the lowest values in the weights of these bears. These are bears between the age of 8 months and 177 months. Now I can pick out, because I've done this so many times, I can pick out what the highest and the lowest are. The smallest bear was 26 pounds and the largest one was 436. So I can do class width without any help on that. The class width would be 436 for this one, minus 26 for that one. And it says I want 6 classes, so I'll divide by 6. And then I will use the technology for my arithmetic because it's simpler. Divide by 6, which comes out to be 68.3. So my class width is going to be 69. I'll round it up to 69 because the bear's weights are all integer values, so I'll round it up to the next integer. Okay? When I make my lower class limits, that's going to be the first numbers that we enter. I'm going to start out with that smallest bear, 26 pounds. And then I'm going to take that 26 and I'm going to add 69 to it. And 26 plus 69 that wasn't what I wanted to do. Is 95, so my next class starts at 95, which tells me that this class ends at 94. And because if I just keep hitting enter, it's going to take the last answer and keep adding 69 to it, I can get all of them relatively quickly. So 95, 164, 233, 302, and 371. So this one stops at 163, this one stops at 232, this one stops at 301, this one stops at 370, and 370 plus 69 is 439, and my 436 will fit in that last class. Okay? Does anybody have any questions about how we did that? Make sure you understand as we're going along, because I'm going to have you show me that you know how to do it on an example in a minute. So make sure you understand now how to do it. So we have our frequency distribution with its lower class limits and its upper class limits. And I didn't ask you to find the midpoints because that's not what we need to do just yet. But now we need to have the frequencies. Now, one way to do this would be to go through looking at the data and saying, okay, I need everything from 26 to 94. So here I have 1, 2, 3, 4, 5. Okay? Count the 5 bears that have that weight. But the thing this gets tedious, especially if you had more than just that little bitty set of numbers. So what I'm going to show you to do, and you can also do this in Excel, but right now we're going to do it on the calculator. I'm going to show you how to do your first statistics problem on your calculator. So we're going to hit Stat. I'll give you a chance to get going with that. We're going to go to Stat, press Enter when it says Edit. I have data in here already, but I'm pretty sure my bare data is going to cover it up. If you wanted to actually get rid of it, you can just sit there and hit the delete button until they all go away. And we can do the same thing over here with the other set of data that I've already got in. So if you've got data in your list, you can clear them out just by deleting each entry individually. And then I'm going to enter in the data from the table. So it's going to be 80, 220. I'm going across the page. 332, and so forth. I'm going to be quiet and let you put your data in however you wanted to enter it. Now make sure you put all of it in list 1. Don't make 5 separate lists because this table is all one variable. It's one set of numbers. It's arranged that way in that grid just to make it more convenient to put it on the page. When you get your data into your list, just look up so that I'll know that you're done. When you get your data in, then you press the Stat button again. You select the second option, sort A, hit enter, then type second L1, which is on the number 1 key, so press the second key and the 1 key. Your second key is in the top upper left corner of your keyboard. And then close the parenthesis and hit enter. And that's what I'm going to do now. So you put your data in. It probably wouldn't be a bad idea to scroll back through it, make sure you didn't have any typos or anything. Then you hit Stat, choose the second option, enter. Second, number 1, because there's a little L1 above the number 1 key. Close the parenthesis. Just like in English class, the teacher wants a punctuation mark at the end of the sentence. In math, if there's an open set of parentheses, you close them. And then you hit enter. And it says done. You're saying, okay, that's nice, what did you do? Go back to Stat and enter and look at your data now. It puts your data into ascending order. Which made it easier to count 1, 2, 3, 4, 5 numbers that were in that first class. Okay? So then our next class goes from 95 to 163. So we start counting at 105. 1, 2, 3, 4, 5, 6, 7. Whoops, nope, just 6 because 166 is too big. So we put a 6 in for that frequency. And then we start counting again. We're going to go from 164 to 232. So 1, 2, 3, 4, 5, 6, 7, and we stop. And then we start again at 233 and we count 262 and go 1. And 332 is too big to go in that class, so there's only 1 in this class. So then we're starting 302 to 370. 1, 2, 3, 4. And that was too big, so we have 4 values in this class. And then 1, 2, we're done. And just to be sure that I did this correctly, I'm going to go back up and look at the table. Let me get our calculator down all the way now. And this is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So there's 25 in the table. 25 there. So this needs to add up to what? 25. Let's see if it does. 5 and 6 is 11, 11 and 7 is 18, 19, 23, 24, 25. And that actually has a symbol. It is lowercase n. It's the number that's in the sample. So those needed to match. Okay? Is everybody okay with that so far? Okay. Let's go back to the lesson for a minute. You have questions. given that the minimum data value is 9 and the maximum data value is 62, if you wanted to construct a frequency distribution with 6 classes, what should be your class width? Use the formula at the top of that page. Second. There you go. I'm just walking around to make sure everybody's got the thank you screen, because that's how I can tell that everybody's done. This thing doesn't catch up very fast. Everybody done? Now, 8 of you didn't answer.
88 of us were right, so.
It's broad percentage.
Oh, okay, 8 people, well, actually on here though, I'm still seeing one, go back. 1, 2, 2 people didn't answer. I'm one of the 2. No, I've got everybody's now. Suddenly it filled everybody's in. Okay? So 96 correct. Good job. Second question, and if you will tap on the table or click on the table, it'll make it bigger for you. Determine the class width of that frequency distribution. Looks like there's about 3 people that still haven't answered. Is that right? Anybody answered? Anybody hasn't? Again, I'm the one that didn't answer. Now, we're going to pick back up here because it's just about time to go. We're going to pick back up here, next class period. You can go into another class. I'm going to leave this one open. It's going to have the same pen. I can give you the pen again if you need to be able to submit it to get back in. So we're going to just stop here.
Can you give us the pin? Is it the same one, the XQ?
Yeah, just leave, if you leave it, is it asking you for it again? Because if I pull it back up, it shows that you're still in.
I'll
The
exit
lesson's still active.
and then I'll go with translation.
Okay. Because it just tells me I still have an active class. So when you log back in here, Bob's going to take you right back to that lesson. Okay? Now, you can leave the lesson if you want to get back in, because I'm going to leave the pen active. Don't forget to turn in your data sheet if you did not.
Oh, hey.